Good morning, everybody, and welcome to our edition of Sci Friday. I have something cool here I want to show you. So right here, I have a Petri dish. I have some Epsom salt. Now this is pure Epsom salt. No lavender, no baking soda, no scents added, just pure Epsom salt. I have some bromothymol blue solution right here. I have a 9-volt battery, and as you can see, I have rubber banded some screws to the top where the terminals are. And I have some right here, some distilled water, okay? All right, so I'm gonna show you something cool here. So first, I'm going to pour some of the distilled water into the Petri dish, okay? And we're gonna go ahead, we're pretty much gonna fill it all the way up. All right, cool. And now I'm going to go ahead, I'm going to add a little bit of the Epsom salt. And I'm gonna give it a good stir. Okay? I'm using an extra little screw I have lying around to stir it, but you can use whatever you like to stir it. You know, I'm gonna try to get it nice and dissolved in here. All right. Now I'm going to add a little bit of the bromothymol blue solution. Now, if you don't have any of the bromothymol blue, you can also use this combustion leak test fluid. It won't work quite as well, but it should still give you some. Decent results. Okay, so I'm going to add a little bit of this. And whoops, spilled a little bit, but that's okay. We spilled a little bit. And then once again, you know, just going to kind of stir it around. I'm going to stir it around real good. Get it all nice and mixed. Awesome. Okay. Now I'm going to go ahead. I'm going to put my little battery. For everybody. So the little jump you saw, we had a slight technical difficulty with our battery. When you do this, you want to make sure that this top part right here is down away from the battery, okay? This top part of the screw should be away from the battery. If it's close to the battery, what can happen is it can touch both the terminal and the casing of the battery at the same time, and then you could end up with a short circuit, which is not fun. So let's go ahead, let's put this little device into our... and let's see what happens. Okay, so we see over on the right side, we see a lot of blue getting made. So again, we see the blue getting made on the right side with a lot of bubbles. Sorry, this part of the audio I am actually adding via voiceover afterwards due to some technical difficulties. And so we see all this blue being made over on the right side along with the bubbles, but we don't see a lot of change going on the left side. And this kind of goes on. We see that blue expanding, going all over our little Petri dish here. And so let's think about what is going on. So water is made up of hydrogen and oxygen. And water can be split into hydrogen and oxygen. And we can do this by running electricity through it. And so there are electrons coming out of the negative terminal of the battery, which is over on your right side as you're viewing this. And those electrons are colliding with the H plus ions in the solution, and they are reducing them into hydrogen gas. So it's taking two H plus ions and reducing it to a hydrogen gas ion. Well, when you take away some H plus ions, you still have some OH minus ions left, which makes that part of the solution basic. And that is making, over on the right side, the indicator is going from green to blue, indicating a basic solution. What I actually don't know is why the reverse is not happening at the other end. Everything I know about chemistry is telling me that over on the other end, you should be using up some OH minus ions, leaving an excess of H plus ions, And because this is bromothymol blue indicator, it should be turning yellow. And I have not been able to figure out why that is not going on. I'm a little perplexed by it. And just in just a few seconds here, we are going to see that I am going to be, oh, you see it right here. So I went ahead and did it again. This part is going to be on fast motion. Um, I ended up accidentally switching the terminals. And so um, now the H plus ions are being used up on the left side. And so that is the negative terminal. The right terminal is not a positive one. And once again, though, we see that all the color change is all happening at one end and nothing is happening at the other end. And I am a little perplexed by this because everything I know about chemistry says that it should be happening at each side. So one side should be going blue, one side should be going yellow, and that does not appear to be happening. And then additionally, once I take the battery out, the solution has gone blue. And everything I know tells me, well, wait a minute here. One side should have lost some H plus ions. One side should have lost some OH minus ions, and it should balance out. Now, one side making twice as many bubbles as the other, or far more bubbles as the other, makes sense because, well, um, water has two hydrogen atoms and one oxygen atom. So one side should be making twice as many bubbles as the other. However, what's going on here is one side is making a lot of bubbles and the other side is making none. And I'm a bit perplexed here. So if anybody has any idea for why this is happening, drop a comment, send me an email, something like that, and maybe we can figure out what's going on.